going to be talking about similar polygons. Some definition. Similar polygons are going to be figures that have the same shape, but not necessarily the same sides. We're going to also talk about congruent, or revisit this, we're having the same measure. Very important concept number one, whenever I'm talking about similar polygons that have two important properties. One, they're going to have corresponding angles that have the same measure. And when I'm looking at ratios of the same lengths of corresponding sides are going to be also equal. Let's take an example of this figure here. If I know that I have got 5 meters is to 8.5 meters will equal the same thing as 12 meters to x meters. Let's see if these are going to be similar. So what I'm going to do is I'm going to set up 5 meters to 8.5 should equal to, same side, 12 meters to x. When I cross multiply these two, I will get 5x equals to 12 times 8.5 should be 102. And when I divide 5 by each side, okay, my missing length is going to be 220.4. So 20.4 will be what my x value is, as long as they have already told me that these are corresponding or similar figures. So when I look at this one, I've got 4 inches, x inches, 8 inches, and 10 inches. This one has actually just been turned over on its side. So I'm going to set up a proportion for x and y. So I'm going to look at the x and y by saying, if I know that for the x value, let's look at it first, I'm going to say 8 over x should equal the same thing as this smaller one is to this side length. So it's going to be equal to 3 over 3.75. So what I have to do is cross multiply, because remember in similar figures, if you cross multiply and they equal each other, they are similar. And they've already told us these are similar. I'm going to say 3 times x is 3x. 8 times 3.75 is going to be 30. And when I divide each side by 3, I know that x is going to be 10. So when I want to look at this, I know that this x is going to be 10. If you notice, this is 3.75, and this also equals 3.75. If I had looked over here, you also see a 10 inches, so this would have to also be equal to 10 inches. Now, how are we going to find the y value? Let's go over here to y, and we're going to set up another proportion. I know 14 is to 10. The exact similarity that y should be to 3.75. So when I solve for these, I'm going to look at it and say 10 times y is going to be 10y, and 14 times 3.75 should give me 52.5. And when I divide each by 10, I know all I have to do here is move my decimal one place over to the left. So y should equal to 5.25. So when I'm looking at this, y will equal to 5.25 because they've already told me they are similar, and that's what they're going to equal to. All right, let's look at some more examples. Here, I've got 2 rectangles, and I want to set up the proportion to see if they're going to actually be similar to each other. I've just shown you how we can make them so we know if they are similar, we can set them up. Let's set these up as 12 over 18. If they are truly similar, should equal to 5 over 7.5. So I'm looking at the same sides of both of my figures. I'm going to cross multiply, and if they equal each other, they are similar in nature. If not, they are not going to be similar polygons. I know that 12 times 7.5 is 90, and I know that 18 times 5 is also 90, so yes, they are going to be similar. All right? Let's look at this. It says if proportion is equal, then the figures are similar. If they are not equal, then I know that there is no similarity in the proportion, even though on paper they may look just alike. All right, what we learned before is I can take these degrees in my angles, and I want to make sure that this 50 degree is going to be right where that 50 degree angle. This 55 is going to be where this 55 degree angle is, and this 75 should be over here where this 75 angle is. If I'm looking at the 55 and 50, this 55 and 50 is really looking like the base that is going to be similar to this base if they're going to be equal to each other. And if you want to just do a little line here to show that these are going to be congruent, and I know that 55 and 75, or 55 and 75, these two should be congruent to this one. And that this angle here, 75 to 50, which is 75 to 50, should be congruent to this one. So these three are going to hatch mark and show me that those should be congruent to each other. So let's see if they are going to be similar. I'm going to say 10 is to 9. And I'm going to look for this hatch mark here for the 10. So I'm going to make it proportionate to 3.5 is to, and if I'm looking at this 9, which is 2 hash marks, is to 3. I'm going to cross multiply these to see if they are equal to each other. And I know that 10 times 3 is going to give me 30. And 9 times 3.5, and I don't have a calculator, so we'll just calculate it over here. That's going to be 45. 9 times 3 is 27, plus 4 is going to be 31.5. And I look at it and say, when I cross multiply, 30 does not equal to 3.5 to 31.5. So I can put a slash through the equals, and these are not similar polygons. So these will not be similar because when I add them together, they do not add up to the same number.